Okay. So last lecture, I think we have started some numericals on boiler, performance of boiler. So, okay, so today we'll start our first with our numerical. So this is the numerical. Whether we have solved this numerical,
Sir, screen not visible.
it is not visible. Okay, now it is visible.
Yes, sir.
Hello. Okay. Now this numerical now try to solve. So last time we have discussed how to solve. Okay. So steam generator evaporates 18,150 kg of water per hour from feed water temperature of 95 degrees Celsius to dry saturated steam at 13 bar. Find the capacity of boiler and its efficiency if 2100 kg of coal of calorific value 30,400 kilojoule per kg are burnt per hour. So this numerically asked, I have taken from the question papers. This is the one or two times this numerical is asked. So whether you can solve, anybody having, if it is yes, you can solve, then write yes, yes and start solving. If anybody having problem, ask me the problem. Can we solve? Anybody having problem, then mention the problem. Or you can write, yes, Kunal is saying that yes, he can solve. Others reply and start solving. Be with calculator, be with steam table, and be with notebook. Okay, Swas and Kunal, they are solving. Others, please reply. Be positive, be interactive. If problem is there, ask me, sir, I have not understand, solve it. I'm going to take try to solve. So this is the problems from assignment booklet which we have prepared with the help of question papers, earlier recent question papers of Solapur University, Solapur. Only two have given reply. Others, Akshay, all others. Am I audible clearly?
Yes, sir.
Okay. Others can reply and start solving. I have to take feedback. Akshay Hetia, Akshay ji, Akshay,
Yes, sir.
are you solving? You
Yes,
can
sir.
able to solve na?
I'm solve it now.
Solving na? Any problem?
No, sir.
You can solve na? Gaurav, Khandilkar, Khandalkar, Gaurav Khandalkar. Others are not replying. Sachin, Sutar, are you in lecture? Sachin,
Yes,
Sutar,
sir.
are you solving?
Ha, sir. Yes, sir.
Any problem, difficulty you are facing? Rishikesh Deshmukh, 17th roll number,
Yes, sir.
solving.
Yes, sir.
Any problem are you facing?
No, sir.
Okay. Okay, students are solving. Okay, I will try. I will help. What is given data? We'll tell those are not present last time or not getting the correct idea to solve this particular problem. So let I will help them. The steam generator evaporates. So what we have to go for? Now here first is what is given data. What is given data? I will tell the steam generator evaporates 18150 kg of water per hour from feed water temperature. So all this water is get converted into steam. So they have not mentioned about the loss. Therefore, what they have given mass of water is equal to mass of steam. Am I right now? Okay, what is given? Somebody can tell. Given data will focus. Shubham Gandule.
Yes, sir.
What is given data? What is given?
सर लास्ट लेक्चरला प्रेझेंट नव्हतं सर.
काय ठीक आहे. सचिन सुतार आहेत का? ऋतुजा कापसे, MS.
Yes, sir.
What is given data? Can you focus? Can you correct?
MS 1150
18150 kg per hour. So whatever water is
Hour.
there, directly it is converting into steam. So therefore there is no loss of water. Then what is given now? Next,
T,
temperature of
T is equal to 95 degrees
feed water.
Celsius.
TW is equal to correct. TW is equal to feed water 95. Then another thing what they have given, steam pressure. So pressure of steam is what? Fish steam you can say. Pressure simply
13 bar.
13 bar.
MF 2100 kg per hour. Kilojoule per kg.
What is given? MF.
MF is equal
MF
to
is
2100
100. What do you need? Kg per hour.
kg.
Kg per hour. Per hour. Burn per hour. Therefore kg per hour. Okay. Then
CV is equal to
CV of the coal.
30400.
CV of the coal is how much?
30400.
30400 kilojoule per
Kilojoule per
kg. Okay. Then what is given next? Okay. This is much given. And what they asked? They asked is calculate, find the capacity. Evaporative capacity we have to find out, and efficiency of boiler. Okay. Or equivalent evaporation we have to find out. Capacity, evaporative capacity, equivalent evaporation, and boiler efficiency we have to find out. Then what is ME? Evaporative capacity is equal to, we'll tell formula. M is equal to MS upon MF. Mass of steam per kg per hour divided by mass of fuel burned kg per hour. And this is equal to, MS is how much MS? We'll tell. Up say MS is 1810 18150 divided by MF is 2100. Capacity of boiler is how much? We'll tell. So efficiency is Kunal got 67%. Okay. Then ME is equal to, anybody? Those are doing calculation. Unit will be kg of steam. Kg of steam. Kg of fuel, or it is coal. Then what is value? 1850 divided by 2100. We'll tell. It may be near about 8 or 8 something. Who is ready with answer?
8.642.
8.642 is kg of steam divided by kg of fuel. Then they ask directly beta boiler. So what is efficiency formula? Next is beta boiler. The formula will be ME we got into HS minus HW. Divided by calorific value. Okay. Calorific value we know, MU we know, HS. Now HS we have to determine. So HS, what is HS now? We'll tell HS is equal to anybody.
2785.4.
But what is HS? Which is quality? Basically, before that, before giving answer, so what is HS? Dry and steam is dry and saturated, and pressure is 13 bar. So what will be HS? What we are going to see from steam table?
HG.
HG. What is the equation? As steam is dry
HS.
and saturated, HS is equal to HG
HG.
at which pressure?
13 bar.
13 bar. Now, pressure is given as 13 bar. Which table we have to refer? Table which we have to refer? Anybody other than
1.
this regular student like Ajit Gaikwad?
Yes, sir.
What HG at 13 bar? Which table we have to refer? Somebody is giving answer. Who is ready with your answer? HS is equal to HG at 13 bar. So we'll tell somebody. No, or something working.
2785.4.
27
85.4.
2785 2785.4 kilojoule per kilojoule per kg. Okay. Then HW is equal to table number 2 we have to write. Which table we have taken? From table number 2 from steam table. Then HW is equal to, who will tell HW is equal to?
HF.
It is a HF at what is temperature of feed water?
95 degrees Celsius.
So table number, which table number we have to go see? Table number 1. Correct? Na? Temperature is given and we have to calculate HW is equal to HF at 95. And what is value? Anybody?
398.
398. Table number 1. To extract this value, we have to go for steam tables. Okay, and I have given lecture. Here I have explained you how to extract data from the steam tables. So kilojoule per kg. 398. Okay. Then put the values in this equation and we got the boiler. The boiler is coming as what? MEU we know, HS we know, and we calculate, put all the values, calorific value we know. So, but take care that calorific value needs to be also in kilojoule per kg. And HS and HW also having the unit kilojoule per kg. That care we have to take. What is the efficiency is coming as? So Shubham Gandole, Shubham Suhas Naste, okay. Then Kunal got efficiency 67.8. Okay, so this was the answer and this is all the numericals for us. Anybody is having problem? My spot is good. So this way we have to solve such numericals. Quality of steam may be dry, quality of steam may be wet, quality of steam may be superheated, and depending on that, we have to find out the values of enthalpies and at feed water temperature HW. Similar same numericals are asked in the examinations. Only thing is there that we have to extract, we can able to extract the data from the steam tables and we should know the appropriate formula. Then all the numericals on this steam tables, boilers, we have made little bit seems easy as compared to the other university syllabus. Okay, everybody got now next. Now this numerical, next
Sir,
numerical. Ah,
hello, sir.
anybody?
Sir, capacity of boiler.
Capacity of boiler in this case, it can be evaporative capacity, no problem. 8.642 divided by kg of steam, because it can be expressed as terms of fuel burned. That is M is equal to MS upon MM. So this will be capacity of boiler 8.642. Evaporative capacity means rate of how much steam is generated from the boiler in kg per hour or per kg of coal. This much is the capacity of the boiler, means for this condition. Okay, so if they are not given information about great area, volume of furnace, so we can, whatever the data is available with us, with respect to that we are calculating the capacity. Okay, or in that additional also we can calculate the data for here equivalent evaporation, value of equivalent evaporation. So calculate in that case, if this is two-way equivalent evaporation is one of the also is a capacity. This is also sufficient, or sometimes you calculate equivalent evaporation. What is the value of equivalent evaporation? MA is equal to ME into okay, ME into bracket HS minus HW divided by 2257. Calculate. And it is one of the evaporative capacity 9.14. We put the value 9.14. Again, unit will be kg of steam divided by kg of fuel. Okay. Then another numerical. I want now this numerical. I will not help. I want answer from your side. Okay. Are you able to solve? Please mention in the message box. Yes, no. Please mention in the message box. Yes, no. Whatever your answer is. Okay. So Shubham Gandole, Shineshwar Misal, Kunal. Okay. Saurabh Shinde. Good, good, good. A similar numerical, but steam is now. What is quality of steam? Quality of steam. Quality of steam is here, not dry and saturated. Quality of steam will be somebody, anybody can unmute. Anybody. Not
Wet steam.
okay. So ask correct. Wet steam. Because why? Dry and inspection is given. Now here pressure is given in terms of kilonewton per meter square. So that we have to convert into bar. Here what is here option is air soil. So pressure is what? Pressure of steam will be pressure is how much given? 750 kilonewton. 750 kilonewton. 750 kilonewton means what? Into 10 raised to 3. Kilonewton means kilo means 10 raised to 3. Newton per meter square means Newton per meter square is nothing but what? Anybody? Newton per meter square means Pascal. Okay, and is equal to Newton Pascal means in bracket it is Newton per meter square. So basic conversion also we should know. And is equal to 5. If you go for then it will be 7.5 into 10 raised to 5 Pascal. And one relation is there in between Pascal and bar. Who will tell that relation? Who will tell that relation? Pascal and bar, one relation is there. What is that bar and Pascal relation? Anybody? Kunal, Suhas. What is that relation? Basic relation.
1 bar is equal to 10 raised to 5 Pascal.
Okay. So then this 7.5 into 10 raised to 5 Pascal, it will become what? How much? 7.5.
7.5 bar.
7.5, correct? 7.5 into 10 raised to 5 divided by 10 raised to 5 is equal to this, and this will get cancelled and we will get answer 7.5 bar. Okay, so this pressure is given as now 7.5 bar. Okay, and this with this pressure now steam is what? Weight x is equal to 0.98. Amount of coal burned is given also. So again another data is given as what? 540 kg of steam. So ms is equal to given as 5400 kg per hour. Okay, pressure is knowing. Okay, T feed water, temperature of feed water is knowing. T feed water. I am writing in short T feed water. You can write feed water, T feed water. So T feed water is equal to what? Here 41 point degree Celsius. Okay, and dry inspection is equal to x 0.98. Okay, and then EMF is 670 and CV is 3100. Determine boiler efficiency and equality operation. So calculate HS, calculate HW, and then afterwards calculate boiler efficiency. Then find out formula you should write eta equivalent evaporation. MA equal to ME into HS minus HW divided by 2, 2, 5, 6. Okay. And ME we know HS now. HS is equal to, we'll tell HS is equal to what? Is equal to HF plus X into HFG. This HF and HFG we have to record at say 1.5 bar. Is equal to HF at say 1.5 bar. Will tell me the value HF at 7.5 bar, HFG at 7.5 bar. Steam table number 2. Now everybody should be perfect. Make practice of using steam table. 7.5. I have given all the variety of numericals on steam table. Interpolation, average, then simple direct straight values. How to extract the with value direct values available. HF and HFG. We'll tell. You can also take out answers. Equivalent evaporation 9.10, efficiency 66.29%. Kunal, now you help me. HF and HFG at
HF is equal to
you can
709.3.
70. Already I think in 1 hour numerical I calculated. 709.3. Whether directly available or we have to take mean extra.
Mean, sir.
Mean we have to take 7.4 and 7.6, correct? Na? One numerical also we have taken. And HFG will be
2055.55.
2055.
0.55.
2055.55. Correct, whatever I have written. Correct, na?
Yes, sir.
2055.55. Okay, and this will be now value is coming as what? HS directly. Enthalpy of weight that weight
2723.
2723.
23.739.
0.73. So I will write, I will consider it as a 74. 739 kilojoule per kg. Okay. Then HW, as usual, HW is equal to HF at feed water temperature. What is feed water temperature?
41.5.
41.5. 41.5. 41.5. 41.5. So HW is equal to what value?
173.7.
173.7. Again, it is kilojoule per kg. Then HS we got, HW we got. Okay. Then ME we know. And then equivalent evaporation is coming as anybody already calculated, na? 9.10. MA 9.10. What will be in it? Unit of evaporative capacity. It is kg of steam. Kg of steam. Divided by kg of fuel. Okay. Another thing they asked is ETA boiler. Sometimes they will also ask the factor of evaporation. The boiler is equal to ME into bracket HS minus HW divided by answer is coming as 66.29%. Only Kunal has got answer. Others, I think what they're doing, I don't know. Suhas means whether are you understood or not? All of you understood or not? Then why? Okay. Suhas also got same answer, 66.30. Good. Suhas and Kunal, except them, others are not understanding in the reality. Then what whether I have to repeat, whether what problems you are facing, you tell na. Kunal, Suhas, except you, others. Shall I ask them personally? Sujit Mane, roll number 42. Okay, Sujit Mane. Okay, Rishikesh Deshmukh, good. Rakesh Biradar, good. Others, who is was there, wanted to unmute and wanted to talk. Then Saurabh Pawar. Saurabh Pawar got answer, same, good. Okay, Shanashra Mishra also got the answer. Saurabh Shinte got answer, good problem. No problem. Okay, shall I take one more problem from assigned booklet? Okay. Have I taken this problem last time?
Yes, sir.
This was taken. Delete this. Okay, so this is our assignment booklet. Is it visible to you? But assignment booklet is visible to you
Yes, sir.
Yes, sir.
clearly?
Yes, sir.
Like, in the- झालं काय पुढची सर मीटिंग हा ढवळे सरांना घ्या now I think this one take 5 zeros. Producing. Okay. So boiler presenting wet steam having dryness factor, working pressure boiler is 12 bar absolute. It generates steam at the rate of 640 and consumes coal at the rate of 80 kg per hour. This numerical also I think we have completed. What balance sheet, losses now only remain and boiling balance sheet. Okay, boiler produces steam and transpiration 0.90 completed. Okay, so all the numericals from question paper or assignment booklet we have completed. Okay, so shall I give one more as a superheated steam? Okay, so write down the numerical. Abhay, Bandgar, anybody? Bandgar, Abhay Bandgar, unmute if you don't want to tell something. And if you're in doubt, you can ask Abhay Bandgar. So next numerical I will tell. From that notebook, if it's some numericals are there, we'll see. Okay, so this we have taken 14 bar. For this numerical, I have we have taken na. First numerical, boiler is working at a pressure of 14 bar. Somebody can help me. 8 kg, 39 degrees Celsius, pit water temperature. Is it completed? It may be completed.
Completed, sir.
Yes, sir.
The boiler is working at a pressure of 14 bar.
Completed.
Okay. Boiler plant supplies for 5.5400 kg of steam. 7. This also completed. In boiler, 1250 kg of coal is consumed in 24 hours. The mass of water evaporated is 13,000 kg. The mean effective pressure is 7 bar. FW temperature is 40. This way, whether you completed? I think not.
No, sir.
Okay, try to complete it.
No, sir.
So in a boiler 1250, in short, you can 1250 kg of coal is consumed in 24 hours. The mass of water evaporated is 13,000 kg. The mean effective pressure is 7 bar. Feed water temperature is 40 degrees Celsius. CV of coal is 30,000 kilojoule per kg. Find eta boiler ME means ME means here MA we can consider here and FE. Okay. Boiler efficiency, equivalent evaporation and factor of evaporation. What do we have to calculate? Boiler efficiency, equivalent evaporation and factor of evaporation. This is symbol MA, factor of equivalent evaporation and factor of evaporation. Three things we have to find out. Can we able to solve? Can we able to solve? Message box put no problem. Steam is quality of steam is given. Okay. So here, as dry inspection is not given and temperature, steam temperature is also not given, then we have to assume that steam is completely evaporated. Means water is completely evaporated, no dry inspection. So steam is a dry and saturated. So write down that first. That as dry inspection is not mentioned, as dry inspection is not mentioned, as well as steam temperature is not given, steam is to be assumed, steam is to be assumed as dry and saturated. So steam is dry and saturated, we have to assume, and then we have to solve. Are you solving? Put message box. Yes, yes, yes. Please solve. Anybody having problem? Am I audible, na? Suhas? Kunal?
Yes, sir.
Okay. Okay. I will resume in 5 minutes. Till that, you complete this numerical. Answer you got answer. Okay. Kunal, whether this numerical are taken? Boiler produce working at a pressure of 20 bar and produces steam at 250 degrees Celsius. Kunal,
Yes, sir. Yes, sir. Taken.
this also taken. Okay, so this is you. Just I will resume in 5 minutes. Okay. So principal sir called me. So just 5 minutes you complete the numerical. Kunal, your answers I think correct. 89 correct. Rakesh brother also good. So I will come within 5 minutes. So just Okay, am I audible?
Yes, sir.
Okay. सर एक 5 मिनिट और लेक्चर कंप्लीट करू. हा हा चालतंय इथेच बसू मग आपण 5 मिनिट. Okay, Swaz got, Rakesh got answers. Okay. Okay, now I think we'll stop the numericals. And now next part is there. So I think this is also we are completed as per Swaz. Okay. So 89%, 11.95, 11.1.14. Shubham, very good. So answer is I think we'll confirm once again. X-ray as well as temperature is not given. This is problem I think. Okay. And H1 is equal to Hg. Efficiency is 89.94, correct. Then ME is 11.95 kg of steam divided by kg of fuel. And FE factor of 1.14. This numerical are completed. Okay. Now here we know that up till now what are the numericals we have solved. So there all the numericals. This is the only exceptional numerical where efficiency came 89%. But in actual case, the efficiency of boiler generally ranges from 60 to 70%. Means what? What this indicates? Anybody? Efficiency of boiler is generally 60 to 70%. Then what will be the conclusion? Anybody? Anybody? Anybody can unmute and tell. Your conclusion, generally efficiency is in between 60, 70, sometimes 50, 55. Okay. Efficiency generally coming as, anybody want to conclude? Okay. Means in that case, only 60 to 75% of heat supplied to the boiler. Means through combustion, we supply the heat to the boiler with the formula we are calculating, that is MF into calorific value. And that out of the total heat supplied to the boiler, okay, only 30, say 60 to 70% heat is utilized from the boiler to convert water into steam. Only 60 to 70% heat is utilized to convert water into steam. But 30 to 40% heat is going in the form of losses. It is not been completely utilized. Okay, so this will be act as a losses from of the boiler. So hence we should study the different heat losses occurs in the boiler plant. Everybody have, okay, agree? So now I will ask who has okay, I will repeat. Okay, then okay. Rakesh Birazlar. Rakesh,
Yes,
okay.
sir.
If boiler's efficiency is 60 to 70%, then what's your why it is 60 to 70%?
सर टोटल जेवढं हिट दिलेलं आहे त्याच्यापेक्षा फक्त 60%च यूज केले जाते सर इव्हॅपोरेशन साठी.
म्हणजे बाकीचं काय होतं?
वेस्ट होते.
वेस्ट म्हणजे लॉस मध्ये. गुड. ओके, राईट डाऊन. नेक्स्ट आर्टिकल यू राईट डाऊन.
हा लॉस.
Heat losses in the boiler plant. Write down. Heat losses in the boiler plant. Heat losses in the boiler plant, or heat losses in the boiler plant. Write down. All amount of heat supplied. All amount of heat supplied. All amount of heat supplied to the boiler. All amount of heat supplied to the boiler. Article you write down. I will also help you. Heat losses in boiler plant. Heat losses in boiler plant. All amount of heat supplied to the boiler is not utilized. Is not utilized to convert water into steam. To convert water into steam. Full stop. Some amount of heat. Some amount of heat. Some amount of heat always go. Some amount of it always go in the form of losses. Some amount of it always go in the form of losses. Some amount of it always goes in the form of losses from the boiler plant. From the boiler plant. Full stop. The various heat losses. The various heat losses occurs in the boiler plant. The various heat losses occurs in the boiler plant are mentioned below. Are mentioned below. Okay, so we'll repeat so that I will repeat. SB 48 roll number Ajit Nadwingal. We'll repeat. Ajit Everton. Internal first. Okay, we written all amount of heat supplied to the boiler is not utilized to convert water into steam. Some amount of it went in the form of losses. The various heat losses in the boiler plant are mentioned below. And in that case, first you write down. Okay. First you write down here heat losses or heat lost by heat lost by dry flue gases. Heat lost by dry flue gases. Heat lost by dry flue gases. Write down. Are you writing, Kunal? Am I,
Yes, sir.
Kunal, Suhas, somebody can reply. Are you
Your
writing?
voice not clear.
Just writing.
Rakesh? Am I audible?
Sir, Not.
Somebody can reply. Yes, Saurabh Shande. Okay. I don't know. When flue gases, when flue gases, when flue gases leaves LEAVS leaves chimney, when flue gases leaves chimney, when flue gases leaves chimney, it will carry, it will carry some amount so heat carried. Anybody can help me? What you are written? I lost my connection. Anybody can help me? What happened today? Nobody is interactive today.
It carries.
Suhas.
The voice break.
Suhas.
When flue gases leave chimney,
Chimney.
it will carry.
It will carry
Uh, from it we return.
it will carry some amount of heat loss. Okay, today I think we'll stop because I think nobody is interacting and I am also getting some internet problem, connectivity problem. Shall I stop today? So in fresh mode, we'll start this article. Already it is 250. Okay, so if all right, only this loss only will complete. So heat carried away, it will carry some amount of heat. It will carry some amount of heat, and it will act, and it will act as a heat loss, and it will act as a heat loss. It will act as a heat loss. Okay, full stop. I don't. This loss can be calculated by the formula. This loss can be calculated by the formula. Write down. Q1 is equal to, next line, Q1 is equal to mg CPG into bracket TG minus TA. What is the formula? Q1 is equal to mg CPG into bracket TG minus TA. Okay. A little mg into CPG into bracket CP mg into bracket Tg minus Ta. Write down where mg is equal to mass of dry flue gases, mass of dry flue gases per kg of fuel. Per kg of fuel. Then Cpg is equal to mean specific heat of dry flue gases. Mean specific heat of dry flue gases. And Tg is temperature of dry flue gases. Temperature of dry flue gases. Temperature of dry flue gases at chimney. Temperature of dry flue gases at chimney. And Ta ambient temperature ambient temperature of boiler room, ambient temperature of boiler room, or boiler room temperature. Simply it is called as boiler room temperature. Okay, so if somebody is repeating this formula, then we'll close today's lecture. Okay, so we will tell what is formula to calculate heat loss due to dry flue gases. Kunal?
Yes. Q1 equal to mg cpg into bracket Tg minus Ta.
Okay, what is mg?
Mass of dry gases G of
Per kg of fuel.
then cpg
Cpg,
mean specific heat dry gases.
okay, Tg is
Temperature of flue gas at chimney and
okay,
A equal to ambient temperature of boiler.
okay, and boiler. Okay, so everybody understood this loss. So then, with your permission, we'll close today because I think internet problem is there. I think Sohas is today. So I'll take attendance first and we'll close.